Algebra 1 Study Guide number 8. Number 1, what is the slope of this line? Now, there's a couple of ways you can do it. You can find some ordered pairs and use the formula, or which we're going to do in number 2. We're given some points, and we'll be actually finding it that way. Or you can count your rise and run. I'm going to use, if you kind of look at it, you'll see that there's a couple of points that are emphasized. We've got a point here and a point here, and you definitely want points that you can easily see on the crosshairs. So I think I'll actually do it both ways. I'm going to go from here to here. It is going up, so I know my slope is positive. And I'm going to go 1, and notice the scale is 1 to 1. So we got 1, 2, 3, 4. So if I go up 4, and that's my rise. And then I'm going to go right 2, and that's my run. So my slope, or M, is equal to my rise, which was 4, and my run, which was positive 2, which simplifies to 2 over 1, or just 2. If you're graphing it, you want it as a fraction. If you're just talking about it, you can leave it just as simplified as 2. Now, if you want to do it with ordered pairs, you can use the same formula we're going to use in number 2, but I would need the ordered pairs. So I could use this point right here as -1, -2. And I could use this point right here, which is 1, positive 2. And if you use this formula, use these points for the formula we're going to use here, it'll give you the exact same answer. So what is the slope of the line containing these 2 points? The slope of a line is the change in the y's over the change in the x's. And this just means you've got 2 points on the line, which I have, and I'm going to subtract the y's on top and subtract the x's on the bottom. And this implies that whatever you start with on the top is what you start with on the bottom. So I'm going to, my y's are 8 and 2, so I'm going to start with the 8. So I'm going to say 8 minus 2, so that's positive 8 minus positive 2, over positive 8 minus -6. See, I'm putting my x's on the bottom, and I'm taking the difference of these two numbers. So I get 8 minus 2, which is 6. And I got 8 minus -6, which is 8 plus 6, which is 14. And I'm going to reduce that by dividing by 2 over 2, and I get 3 over 7. Oop, there you go. Number 3, lesson 42. What is 35% of 84? Well, is your equals, and of is your time. So what is your unknown? X equals 35%. I need to write it as a fraction or as a decimal. And I'm going to use... Okay, that's a little blurred. Let me see if I can get that a little clearer. I'm going to use it as a decimal. I like 0.35. Of is my times 84. So x is already by itself. I just need to do multiplication. Let's scoot over, and I'm going to put the 84 on top. It's commutative, so it doesn't matter which one you put on top. So 4 times 5 is 20. Carry 2. 40 plus 2 is 42. 3 times 4 is 12. Carry 1. 8 times 3 is 24, plus 1 is 25. So we've got 0, 4, 9, 2 with our 2 decimal places. So x is equal to 29 and 4/10, or 40/100 if you want to put the 0 on it. Number 4, it says lesson 28. I think we actually did this. I think it's 27C. It's the lesson on equations with fractions. Now in this case you're distributing a fraction, so if you'll watch me set it up, and I think I'm going to come over here, I think you can see it. If I come over here and distribute my 1/3, I'll have 7x over 3. It's just 1 times 7x, 3 times 1, minus 4/3 is equal to 7. I'm going to go ahead and put a 1 under that, minus 6x, and I'm going to go ahead and put a 1 under that because I need common denominator. So obviously the denominator needs to be a number that 3 and 1 will go into, which is 3 is the smallest. So let's multiply this one by 3 over 3 and this one by 3 over 3. So we'll have 7x over 3 minus 4 over 3 equals 21 over 3 minus 18x over 3. You can multiply everything by 3 and clear out your denominators, and we'll have 7x minus 4 equals 21 minus 18x. Now I like to move my x's first, so I'm going to, start dropping everything. I'm going to move my x's first, so I'm going to add the 18x to both sides. So I have 25x minus 4 equals 21. Now let's add the 4. 25x equals 25. Divide by 25, and x equals 1. Number 5, lesson 42. Okay, again, is my equals, of is my times, and this is my unknown. So I'm going to put 29.7 equals, I like to put a p for what percent. That just helps me remember to write it as a percent, times of 22. Well, notice 22 is attached to my p by multiplication, so I need to get p by itself, so I've got to do the same thing to both sides. So let's come over here and do our division, do our scratch work. Okay, 22 goes into 29 one time. Subtract, I get 7, and bring down my 7. 22 will go into 77 3 times, 66. Subtract, we get 11, add a 0, bring it down, and we'll keep dividing until it ends or repeats. And 22 actually will go 110 5 times. So I get p is equal to, now watch carefully, p is 1.35, which is a decimal, but as a fraction, that is going to be, let me try that again, that is a decimal, but as a percent, I'm going to move my decimal place over 2 spaces to the right, and I get 135%. Now, if you need a little extra help on that one, you've got 135, 1 and 35 hundredths, and anytime you want to change a decimal to a percent, you can just multiply it by 100%. That's just multiplying by 1. And 100 will get the 2 decimal places over, and then the percent sign. So that's just a little extra notation there if you need help with that one. Okay, number 6, another type of percent problem. 25% of what, that's your unknown, is 300. So 0.25 times x is 300. We need to get rid of the 25 hundredths. Now let's go over here, let's find a place, and let's divide 25 hundredths into 300. Okay, I need to get rid of my decimal in my divisor. Well, when I do that, I'm going to have to move it over to here. 25 goes 1 time. 25 goes 2 times. So at that point, all I'm doing is bringing down zeros and dividing. And so x is equal to 1,200 or 1,200. Number 7. Simplify, we're going to distribute, and we do have a little canceling, but I'm going to go ahead and show both steps and not do the canceling as in my first step. So let's distribute. So on top I have, I'm going to put them in alphabetical order. So I've got 2a to the 6b over a cubed b minus 5a to the 6b squared over a to the 6b. All I did was just distribute. A to the 6b times this times that. Now let's see what we can reduce. Well, I've got 2 on top. I've got 6 a's and 3 a's. So if I cancel, I have 3 a's left on top. And my b's are gone. So I've got 2a cubed over 1, or just 2a cubed, minus my a to the 6's are gone, and one of my b's is gone. So I'm left with 5 on top, and I'll be left a b on top. You can put 1 under those if you want to. That's it simplified. Number 8 is lesson 40. Now this is probably not a direct example from 40, but it's just implied area of a square, and it'll make sense if you'll draw a picture. So you have a square tile that has a side of 4x inches. So let's draw a square, and we know that the sides are the same all the way around. I'm going to put it all the way around it. And they want its area. Well, the area, a square is a rectangle, and it's going to be length times width, which are the same measurements. So the length is 4x, and the height is 4x, base height, whichever way you want to say it. So 4 times 4 is 16. X times x is x squared, and our units were inches squared. Number 9, water flows into a swimming pool at a constant speed as shown in the table. What is the rate of change? Don't forget the units. So we have to look. Well, we see it's going to be my y's, my dependent variable over my independent variable. So it's going to be, our units are going to be gallons per minute. So rate of change is just slope. So pick 2 points. They all look pretty easy. I'm going to pick these two. So I'm going to do rate of change, R of C, is equal to the change in the y's, which would be my gallons. I'm going to do the 32 minus 16. So if I start with the 32 here, I'm going to start with the 8 on the bottom, over 8 minus 4, which is 16 over 4, which reduces to 4. And then remember, our units were gallons per minute. So the swimming pool is filling up at 4 gallons every minute.